happening in this place. We are going to talk to you a little bit about who we are, what we do, and then show you some really cool things that we do with our tools that might be able to help you in your development, but more importantly, to spark ideas, because every development tool chain is different, every workflow is different, and you're going to adapt these to yourself and your employer or your personal workflow. And then we're even going to have a developer who uses WSL exclusively come up and kind of talk to you about how he incorporated WSL in to his workflow. So first off, Penguin is a distro for WSL. It was created by WSL users for WSL users. It's WSL native. It can be built on WSL from beginning to end. We're a small team, 4 folks, all remote, all around the world. Myself, Patrick, Carlos, and Kim. Myself, I'm the founder and the project manager. I've been on Linux and Unix for about 15 years. I actually left Windows around 2006 for Mac OS for my development needs. I returned to Windows in 2018 because of WSL. I maintain documentation. I'm from Georgia. Patrick here is our lead developer. He maintained WSL utilities before Penguin came around. We now make WSL utilities available for all of the distros on WSL. They're a set of tools that make interoperating between Windows and Linux on WSL even easier than they already are. He studies computer science in Hong Kong. Carlos is our senior software developer. He developed our Docker bridge, which we'll talk more about later. He contributes to Wine. He's in the top 5% for Docker on Stack Overflow, and he has worked for more than 15 years in election software. Basically, if you vote outside of the United States, you've probably used his election software. He now lives in Spain. Kim is another one of our developers, former physicist, Java programmer. She's our InfoSec specialist. She commits to the Linux kernel and is based out of the UK. So why did WSL need its own Linux distribution? What was the inspiration? What are some details? What are some of our features? And what are the use cases? So Penguin started as WLinux. As I mentioned before, it was by and for WSL users. It put WSL needs first, unlike the other distributions available. It bakes in a number of optimizations for GUI apps, for speed, for font support, other features that our users really enjoy. It's based on Debian testing, currently Buster. So we try to get new packages, not necessarily the latest, from unstable, but something that have been tested somewhat. We then slipstream our own custom packages in, built from GitHub using the CI/CD system based on Circle CI and Package Cloud. One of the very powerful tools that we ship with Penguin is Penguin Setup. It includes a number of hand-curated development tool chains so that you can get started right away in your preferred language. You have your choice of shells, curated programming language workflows, a secure bridge to Docker, that is Docker running on Windows. We now know, thanks to WSL2, that Docker will run once WSL2 is released in WSL2 without a secure bridge. But that will be coming later. For now, you can use this option to access Docker, and we'll be showing you some examples of that here soon. We have Explorer shell integration, home folder backup, and because our distro is very popular outside of the United States, particularly in Asia, we have improved non-Latin keyboard input. We actually released this on the Microsoft Store for x86 and ARM. We pay 10 bucks. We ask for 10 bucks to help support ongoing development. It's open source though, and you can build it from code yourself. We also make Penguin Enterprise available. I promise this is not an ad for Penguin, but we're just going to touch on our experience here in this area. It's a custom WSL solution for secure deployments. This was based on enterprise demand. More and more companies are picking up WSL and using it in their development workflows, but companies and enterprise being what they are, they like to lock those down and use a stable, supported distribution like RHEL, like CentOS, like Scientific Linux, like Oracle Linux, and we make that available along with deployment consulting. So a lot of companies want to use WSL and they're not sure how to get started. We help them get started. Penguin Enterprise supports Red Hat, Oracle, CentOS, and Scientific Linux. So we make that available directly to enterprise, and we also make a demo available on the store built with Scientific Linux. We also, as part of our commitment to open source and upstream projects, make Fedora Remix available for WSL in collaboration with the Fedora community. We also make builds of that available on GitHub and via Chocolatey. As I mentioned before, we're very active in the open source community. We submit bug reports and patches upstream to distros and projects, things we encounter not only building our distributions, but also software to make sure it's compatible with the most machines possible. We sponsor open source events, we raise funds for science education, we try to be good stewards in this area. So why Windows Subsystem for Linux? First, what geek looks at a piece of technology and says, can it run Linux? Can we put Linux on it? Of course we do. This is actually a Nintendo Switch running KDE Desktop, because why not? It gives you powerful open source tools to develop with, and what we really believe is that WSL and Penguin are the next generation of tools that fall in the family of Cygwin, CoLinux, for those of you who might remember that, and the little-known Windows services for Unix, which existed for several years. We are also part of the new Microsoft, which is embracing open source. Just today, with WSL 2, which will have an open source-based Linux kernel and an open source-based terminal, we now add that to open source involvement in GitHub, .NET Core, PowerShell, Linux on Azure, Code, and last but not least, Windows Calculator. So WSL, how many people currently use WSL? Okay, so a lot of you. So a lot of you know it just works for most tasks. Command line tools primarily, most GUI tools, you're mounting C and removable media, you've got networking and serial connections. What doesn't work yet? And that's native Docker, yet. I had to put that in there. We knew something was coming down the line. That is coming soon. For now, we have our secure bridge to Docker. Systemd doesn't work. There's no init system, as I'll show you. Accelerated graphics, you know, it's really high on the user voice votes. The team is aware of the request. It doesn't exist yet. Audio, you can make work if you want to build Pulse Audio for Windows. Low-level networking functions such as IP tables, EB tables, other functions. We're going to have to see what works and what doesn't in WSL 2, but right now it doesn't. WSL, it lets you do cool things as a developer and a sysadmin. You're building and testing cross-platform applications. You're leveraging Windows and Linux dev tools simultaneously with each other, and you can manage your Windows and Linux environments from one device. And I'm going to show you some examples of how we do that here in a little bit. So we're starting to get noticed outside of just Microsoft. Here's an article that appeared just a couple days ago on the official Red Hat developer blog about using OpenShift on Windows, and they recommend using it with WSL. So there it is. So I want to jump right into demos because this is a breakout session and advanced, and we want to show you some cool things. We're going to break it up into two parts, developer and then ops. And the story we're telling today is, for those of you who aren't familiar with WSL, we're going to introduce how to get started. We're going to link WSL to a development environment. We're going to build some small apps. And then we're going to go in depth building a ASP.NET app. We are going to test it locally. We're going to deploy it to Azure. And then we're going to deploy it to a local Linux server to accelerate on-site use. And then we're going to give a developer on a Windows device access to WSL remotely using WSL. This workflow, this walkthrough, is completely online at penguin.dev/build2019, and it's on GitHub as well. So you can try all of the code and go back through and try all of these things yourself later. So it might be tough to keep up if you're on your own device, so we made this available. First, we're going to get acquainted with WSL and build our environment. So those of you who don't have WSL enabled, the easiest way is with PowerShell. It's a simple command, enable Windows Subsystem for Linux. If you're not in PowerShell or you just want to move even quicker through GUI, honestly, the fastest way is Windows, turn Windows features on and off, scroll down to the bottom, enable Windows Subsystem for Linux, restart, and you're good to go. Okay, now we have Windows Subsystem for Linux activated. Where do we go to get our distributions? The Microsoft Store. So you can search for your favorite distributions, of course, plug for Penguin, but you also have Debian. You have Ubuntu, OpenSUSE, our Fedora Remix, Penguin Enterprise. So you have your choice. And if you want to get really advanced, you can even build in your own distro if one of the distros you prefer to use is not available in the store. So how do we start Penguin? This one's tough. There we go. Penguin is started. So how do we start building our environment? Pretty simple, just like we would on any Debian-based Linux. And if you haven't had a chance to go by the WSL booth over in the convention center and let them show you how WSL2, how fast it is, it does this in about a quarter of the time, if not less. So WSL is getting faster as that iterates. So we've got that installed. Let's go to our desktop. All right, we're on our desktop. And I want to clone this repo where I have some code samples saved. And for those of you who aren't familiar with WSL or have just heard about it, WSL is not emulation and it's not virtualization. These are Linux binaries being executed on the fly through a translation layer that's probably more akin to Wine than an emulator, except where the open source Wine project implements Windows API calls on Mac OS and Linux. What's being implemented here are very basic Linux syscalls, and those syscalls are being translated on the fly from Linux to NT syscalls. Now, that's going to be changing because in WSL2, which was announced today, there will be an actual Linux kernel running in WSL2. It'll be based roughly on 4.19. It'll track the most recent stable Linux kernel, and it will be much faster. It will be it'll be more virtualization than this. So it'll be closer to the new Windows Sandbox features. It's based similar to Hyper-V, but it does not require Hyper-V. So you will be able to run it on Windows Home and devices that don't otherwise come with Hyper-V, which means also you'll be able to run full Docker without Windows Pro for those users that don't have Windows Pro devices. All right, moving forward. Okay, we're going to go into our... All right, we've got a simple C program ready to go. Hello build 2019. And we're going to build that with GCC. Nope. There we go. All right. And we've got a Linux app running on Windows. But let's say we want to compile the same app for Windows. All right. We've got the toolchain for that installed, and we build that. We drop into command prompt. Hello build 2019. So we've just right back to back built Linux and Windows binaries back to back using GCC. So we're going to exit out of there. Now let's talk about those GUI apps that people prefer to use. So I prefer X410. There's a couple others you can choose from. It's now running down there. And we're going to open and there we go. So we've now got, so for developers coming over from Linux, who are accustomed to Linux dev tools, they should find themselves right at home in this environment with Genie, with GNOME Builder, with Qt Creator, any of those Linux tools that you may be familiar with, you can now develop with on Windows, and then compile those tools in many cases for both Windows and Linux. The lines are really blurring. So let's build a simple development environment. So we're going to install Python. I've installed Python already because it takes a little bit. And then we're going to link it to VS Code. Here again, Microsoft surprised us a couple days ago with new features for code that link code and WSL. So I'm going to show you really briefly the old way, which is the way we have to do it for the next couple weeks, and then the new way you can do it on Insider's branch of code in order to build on Windows, but have the actual execution and your dependencies managed in Linux. So let me show you real quick. So the old way would be to open code, do control comma, open our settings, go to terminal integrated shell.windows. Normally this would be PowerShell. All we do is we put in the executable reference for our distribution. You can change this to Debian, you can change this to Ubuntu, and you can open a terminal. And there you go. So you have access to the terminal right from code. This is how we used to do it. It had some limitations. Linting was an issue. The extensions didn't quite work. A lot of users tried to use code directly on WSL, which kind of worked but broke a lot. Thankfully, Microsoft has a new solution for us. Now this is the insider's build, and you can go to extensions, and there's now a feature called Remote WSL. And we can launch a new window of Visual Studio Code, and we are linked now. It's going to install some components, and it right now it does this. Oh, there we go. Good. So we're now linked to WSL, and we are so linked that when we go to open a file, it's going to ask us for our Linux environment tools. So we can code directly in the WSL environment without ever leaving code. Now, how does this become useful? Let's go back to our thing. All right, so first we're going to we're going to build a small app just out of the gate. So we're going to make sure Flask is installed. Ah, yes, thank you. All right, we're good to go. Let's go. So we're going to see. We're going to that folder we created. We're going to open it. A second, okay, and make sure we're good. And what we've opened here, I've just created a small little Python app with the Flask dependency. Flask, for those of you who aren't familiar, is just a Python web service micro framework for building quick, small Python web apps. And we can do that with okay, so it's running, and we can open a new tab, Penguin. WSL view. Let's just make sure there's no mistakes here. Copy and paste it. There we go. Hello Build 2019. So we built that in code on WSL. We're running from WSL. It's very simple to start out with. We're going to get more complicated here pretty quickly, but I just wanted to get you kind of acquainted with how these dev tools interact with WSL, and we're going to move on now to something even more detailed. So we're going to start SSH on our instance of WSL. So that's running. That's good. And then we're going to go to Visual Studio 2019. We're going to create a new project. We're going to make, so the idea here is that we work for a company, we need a web app, we're going with ASP.NET, we want to build it, we want to test it locally, we want to push it to Azure to maybe do some performance testing, but then we're going to deploy it locally as these environments become more mixed, where you might have some off-site services and some local services, and you want your local team to have faster access to the services than maybe people in the field where they have to connect to the Azure instance. We're just going to create a blank one. Web application template. All the defaults are fine. We're done with you for now. Okay. So of course, we can take our blank template and build and test, and it'll open. And that's fine. We're testing it on built-in IIS, so we can make sure our application runs on IIS. Oh, that's not good. Let's go see what that's about. Well, we knew something would go wrong during the demo, but we can continue. Yeah, maybe that's a good idea. Let's go close that out, see if that makes a difference. There we go, Patrick for the win. Thanks. All right, so we're testing locally in Visual Studio. Nothing too groundbreaking here. But let's go see how our .NET app, ASP.NET app, functions on Linux, and how can we debug it even while it's running on Linux from Visual Studio. So we're going to our Penguin instance. We are going to make sure we restore all of our dependencies. Usually doesn't take too long. Give it a second. Okay.
I think you just deploy it without stopping.
Yeah. There we go. Aha. Saved me again. And there we are. So we're running our .NET app locally on WSL. So we've built it and tested it on Windows and Linux. It tests locally. Now what do we do with it? Okay. First, let's make sure we can debug any issues that come up. We can actually do that even when it's running on Linux by attaching to it, and you can do this locally or remotely. We're going to debug, we're going to attach the process, we're going to switch to SSH, we want localhost, find, nope, refresh. We're going to log in. In production, you should use keys. Okay. And now we can find our .NET processes and debug, set breakpoints, even while it's running on WSL from Visual Studio. select Manage .NET Core for Unix. It's going to inject some interesting tools into our WSL environment, and you can debug locally. There we go. So whatever debugging processes you follow, breakpoints, etc., you now have access to that from Visual Studio running while it's running in WSL. So Visual Studio doesn't limit you to just debugging these on Windows. You're also welcome to debug them running on Linux. Visual Studio is now a cross-platform development tool. Okay. All right. So now I'm going to turn over to my lead developer, Patrick, and what we're going to do is we're going to package this very basic web app up, Dockerize it, and then push it to Azure. So you want to take over?
Yes. So now we will try to Dockerizing our app using the Docker on Linux on WSL. And this Docker is our secure Docker bridge installed from the Penguin setup, and currently it's already set up. So you can already see that it is a Docker in WSL, not a Docker on Windows. So what we are trying to do here is we are going to use a third-party app called Dive to build our app and analyze the layers of the image. So let's move to the folder first. You can download Dive from our GitHub page, and there's instruction here. And we already installed Dive inside the Penguin, so we will just dive in. So now I will copy the Docker file from our GitHub. God.
You're good.
So we just copy the Docker file from our repo, and we can take a look of the Docker file. So you can see we are using a really simple Docker file to try to build the this .NET web application, and we will use the runtime image to run this app. So now we are going to build it. using dive. So now the image is built and is passed to the dive command line app. So like we can see that the app the application is successfully copied to the image. So it's good. So now we are going to run the app from Docker on WSL. So what we do is simply do this. And now it's running. So forget about it is HTTP one. So yeah, now it is up and running, and you can see that it is running now on Linux, on Docker, in Penguin. So now we will try to deploy this Docker image to Azure Container Registry. So what we are going to do here is we will use the Azure command line interface to deploy this Docker image to the Azure Container Registry, and you can install it using Penguin Setup too. And it is already installed here, so I'm not going to go through this step. So firstly, we are going to log in.
We're already logged in.
Okay.
We can skip that step.
So yeah, we already logged in, so we are trying to create our Azure Container Registry. So yeah, it succeeds. So let's now create the container registry. Now you can see it's created. It successfully created the container registry. So we are going to log in to this Azure container registry. Yeah, login succeed. So now we need to retrieve the image retrieve URI, and
and while he's doing that, I just wanted to point out how much of this process that can be automated, working with Azure and deploying these containers using the bash shell, using variables, parsing those variables, so that you can script this from beginning to end.
So as you can see, the registry URI is already up. So let's tag our Docker image and get started to push Docker image to Azure registry. Now it is tagged, so I will push the image to the registry. It takes some time. Great. It is now pushed to the website. So now we will enable the writes and get the registry passphrase, but don't do it in the production. Use Azure Key Vault instead. And now we were going to deploy our container to the to the site. Still running.
So what you'll see in the next command, if you'll switch back to the browser while it runs, so what we're actually doing here is we're using screen just went blank. We're using JQ, which is a Linux command line tool for parsing JSON output, so that we can then quickly extract the IP address of our new instance of this Docker app.
So now it is running, so we will retrieve the IP address, and then we'll take a look. So yeah, it successfully deploys to the Azure container registry. So what we're gonna do next is we are actually using the container registry and push the container to a remote Linux server with Ansible. You can also install Ansible with Penguin Setup, and it is also but currently we are already installed in the demo machine, so we are not going to show how to install it. And so we are going to now create a host file. So now we will generate and copy SSH keys to the remote machine. And this is only necessary for the first time connecting. So now we'll generate a sample SSH key. So we'll leave everything as default. And then we'll copy the SSH key to the remote machine. Yep. Now it is added. So now let's test the connection with the Ansible. So this message will, if send, it will, if it succeed, it will give a message back called pong. Yeah. So now we are ready to deploy the container to the server, container to the remote Linux server with Ansible. So now we are going to copy the Ansible playbook to here. So and we're going to take a look.
So what this Ansible playbook does is it installs all our dependencies for Docker, makes sure Docker's installed, adds Docker if it's not necessary, updates the apt cache on a Debian server, installs all the Azure tools necessary. And one thing you'll notice is that it actually imports the variables, our environmental variables that we created in our earlier tasks directly into the Ansible script as it deploys. So this is another example of the automation that you can use with Ansible on WSL. And you'll see in the command line, it passes those that have already been generated. So that you don't have to go find those, look those up, type more commands for those. It's just one command.
So now I will deploy the container registry container to the remote WSL, to a remote Linux machine using Ansible playbook command.
And it's going to make sure all those dependencies are installed. Those of you who aren't familiar with Ansible, it's a playbook-based system that manages remote systems, everything from basic system configuration to deployment of apps. And it's just one of these neat tools you can combine with Docker on WSL to move your apps around, manage them, update them, keep them secure. And that's not just on Linux as well, that can be used on Windows. So you'll see that our playbook is actually logging directly into our container registry, pulling the image, spinning it up, and we're good to go. So let's give it a test, make sure it's running. Yep.
Yeah, it's running.
Okay. So I'm going to take back over from here. So we're running short on time. There's a couple more things I had wanted to show you. So please check out the GitHub to take a look at those. The next thing we wanted to show you is how to deploy Windows packages on Windows machines using WSL, using Chocolatey. And the example we picked was actually Fedora Remix for WSL. So you could, on WSL, deploy WSL to other Windows machines, set them up, configure them, run software updates, apply certain security features, all remotely, all using the same platform. So we have about 5 minutes left. I wanted to bring up a special guest, Spyro. He is a senior developer from Zolo, senior developer at CATSA, the equivalent of the TSA in Canada, senior developer This Week in Tech Network. He's done a lot of work, and he's just going to talk briefly about how WSL has changed his workflow.
Hello, folks. So I'm just going to briefly talk about how I use WSL with what I do. It's completely anecdotal. Your mileage will vary. But I primarily am a freelance full-stack web developer. And when WSL first came out, I just kind of started poking around and eventually found myself deeply invested in it. It just became part of my workflow naturally. So what I primarily do with WSL is my entire web development build tool chain is installed and running on it. So I almost exclusively code in it now using tmux and Vim. If you don't know what it is, Google that. And anything that I need to build, whether it's post-processors, pre-processors, Python, Ruby, Node, whatever it is, it's all built and running on WSL. And sometimes I'll use like Visual Studio Code or Sublime Text, like an actual IDE. But most of the time I find myself in Vim now. WSL kind of opened that door because it let me interop with Windows. As a freelancer too, what happens is sometimes you'll get a variety of contracts and clients, and they have different requirements. I still have to support IE11 sometimes, which is crazy. And sometimes there are restrictions on the kinds of systems software that I can run and build with for certain clients that require me to be on Windows to use Windows tools. So with WSL, I don't have to worry about what's going on between the two systems anymore. I don't have to dual boot. I don't have to worry about a VM. I don't have to have a separate machine for my Linux stuff and my Windows stuff. It's all in one. And also as a freelancer, sometimes you get interrupted in the middle of your day. You're working on one client's project and another client calls you and there's an emergency and I need to work on both. Sometimes I don't have access to a second machine to be able to jump for 5 minutes and deal with an emergency on a Windows machine and then jump back to my regular Linux. Again, WSL, don't have to worry about it. It's not a perfect system. WSL2 fixes a lot of stuff that is kind of maybe slow right now, I/O performance, things like that. But in the gains that I personally have gathered from WSL are much bigger than any of the downsides of using WSL as it currently is today, and it's only going to get better. So that's just a brief overview of how I use it.
Thank you so much.
Thanks.
We have a few minutes left. Any questions? All right. Yes, please. The question was WSL Remote only available? Yes, WSL Remote, the extension is currently only available on Visual Studio Code Insiders. Yes. Yeah, it was just released a couple days ago. So, any other? Miss anything? Okay. This is F.org, by the way. It's a great Gopher client if you wanted to check out Gopher Space while you're on Penguin. For those of you who are nerds like I am. I just wanted to thank the WSL team at Microsoft. Go check them out over at the other facility, Debian and Fedora, our partners at Red Hat, our friends at Chocolatey and Oracle, all the WSL community members, the real Ken, WSL Corsair, Neil Gumpa, Andrew Fair, others. And we wanted to do a quick one more thing. We are currently working on a GUI interface that will allow you to one-click install and manage several different distros from the same Windows device, even easier than installing from the store. All right? Thank you so much for coming. We really appreciate your time. We hope that you learned something. I know some of the things we did were pretty basic, but the idea was to show you how these things work together across tools, across platforms, and you guys can go and take and add on those and create more complex applications that you need for your employer, for your personal projects, etc. Okay? We'll be here for a few minutes to answer any questions. We've got stickers here and at the back, and we look forward to hearing from all of you. Thank you so much.